Good morning, my name is Gretchen Ayers, and today I wanted to share with you my professional development that I shared with the administration and teachers at my school so you can have a better understanding of my research. My research was using the engineering design process to improve STEM prototypes within the English language learner population. And I am the science lab teacher at the school, so I was able to do this with many grade levels. Here's the things we're going to be going over: my action research, key terms, background research, my methods, my findings, discussion, and future research. The two research questions that drove my research was, what do you do as a teacher to implement STEM prototypes, and how to measure change and growth of ELLs in scientific learning. So here's some key terms that you might need to know as I go through the PowerPoint. EDP stands for the engineering design process. ELL is English language learners. STEM stands for science, technology, engineering, and math. And STEM prototypes are things that students make. They're like a model or a design of something that involves a STEM challenge. So when I was doing my background research, I found out that STEM has been around since 2001. Before that, it was named SMIT, Science, Math, Engineering, and Technology. So it was just the letters rearranged. I found that ELL students are able to express their learning better when they are provided hands-on science experience. At my school, we currently have 45% of students that are ELLs, so this was a significant number, so that's why I chose this group of students. Since more than half of fifth grade students received a score of 1 on the Georgia Milestone Test, it was a critical issue to address at our highly populated ELL school. The significance of the research: McClure found that in order for all students to succeed in the STEM-focused future, teachers must spark an interest of STEM at a young age. So since I am teaching pre-K through 5, I feel like this is very important and significant. The action research will investigate the impact that the engineering design process has on STEM with ELL learners. And my hope is that this will provide a fair chance for all the students at our school to thrive in their future. Since there's such a high focus on STEM jobs, it's essential to offer students this organizational tool, which is the engineering design process, to work towards a deeper understanding and concepts. So here are my participants. Class A and B are 3rd grade classes. Class C and D are 4th grade classes, and Class E and F are 5th grade classes. Each grade level has a treatment group and a control group. So one group received the EDP, they were able to use an organizational tool, and the other group was not able to use the organizational tool. I wanted to see if using that engineering design process made a difference in the understanding of a scientific concept. So it's conducted in Atlanta, Georgia. My school's actually in Smyrna, Georgia, with a population of 45% ELL and 87.2% free and reduced lunch. The STEM is a limitless process for ELL students to have a safe place to practice language skills and interact with others during meaningful content conversations. So that's something that another researcher found. This is my timeline of the research. I started on February 12th with the pretest. Then we went into the introductions of the lessons. Then they were able to go through the engineering design process. So this is a large time period here, but it took about 3 rotations. Each rotation takes 7 days to complete in the specialist schedule. On March 9th, we started the post-test data collection. After the post-test was finished, I had a few days to do the data analysis. I wrote up my findings and discussion, and I was able to write the full action research paper after. Then I did a professional development plan. On March 28th, I was able to present this PowerPoint at the staff meeting with each grade level, and then I was able to do some reflecting after the professional development. The major part of my data collection was done through Microsoft Forms. Each grade level had a pre-test and post-test created, and they were completed on an iPad. Here's an example of what the third grade groups looked like. Here's an example of fourth grade questions, and here's an example of fifth grade questions. I shared this at my professional development so that teachers would know about this tool that they can use. It presents the information, the data right away in a graphic form, and it gives you the numbers as well. So I found this tool very useful. Here is the third grade lesson that the students completed with the challenge, the criteria, and the constraints. And you can also see students at work and some finished products. Here's the fourth grade lesson, students at work. This is an example of the engineering design process organizational tool. So this group was able to use it. Here's the fifth grade lesson. The students are at work building their electromagnetic cranes. Each challenge had the challenge, the criteria, and constraints. Capitelli's research in 2016 says that ELLs gain English language development accredited to the engineering design process. So here's a picture of what the engineering design process looks like, the organizational tool the students used in this specific research. And it goes step by step: ask, imagine, plan, create, and evaluate. Okay, next is my findings. The treatment class is first and the control class is next. My findings were a little surprising to me. The blue is the pre-test and the green is the post-test. On the XY axis, you can see the average test score and the grade level. So starting with third grade, you can see the pre-test and post-test data is a little shocking to me. They actually went down. Same thing for fourth grade in both the treatment and control. Now, if you look at fifth grade, you can see that there is a difference here. Fifth grade with the pre-test and post-test, they both scored higher. But with the treatment class, the class that received the engineering design process, they did improve by 2 points more. So there's a decrease in the post-test class average compared to the pre-test average in both the treatment and control groups in third and fourth grade classes. There's an increase in averages in fifth grade students between the treatment and control group, with a larger increase in treatment group. So on my discussion pages, I wanted to go ahead and throw out some things that I was thinking about to try to drive the discussion because some of the teachers were not ready to talk yet. So I shared some of my discussion. I shared about the lesson plans. I found that the third grade lesson closely resembled a theme rather than linking directly to the content. So with the lesson plan in the third grade, they were designing a prototype of a turtle that lived in a Georgia habitat. The fifth grade lesson was designing an electromagnet, and that one related directly to the content, and I think students were able to achieve more on the test because they were actually building an electromagnet. It wasn't a theme of a turtle, or like the fourth grade lesson, they showed a slight decrease, while the fifth grade showed a slight increase in the treatment and control group on the pre-test and post-test. Fourth grade, they were also making a prototype of the moon, the earth, and the sun to show the moon phases. So this showed me that a lesson plan doesn't need to be themed. It needs to be more focused on the content instead of just directly focusing it to a theme, if that makes sense. Okay, I also talked about the limitations at this point. It was a small sample size. This was only 2 classes from each grade level instead of the whole school. Also, time and scheduling is a factor. Since we're on a rotation schedule, I only get to see the students every 7 days for 50 minutes. I think it would have been different if I had seen the students all in one sitting, or back-to-back days instead of spaced out 7 days. The ability of the class makeup is another limitation. At our school, we have most of our gifted students are in one class mixed in with a few others. And then our ELL students, we have teachers who are ELL certified, so they put a lot of those students in one classroom. So the ability level of the class could also be a limitation. Another limitation is due to missed classes. So some students miss classes due to conferences, field trips, or assemblies, and that also affected the research. Okay, so part of the research cycle is looking into the future. What type of future research I would like to do is look into more survey development so I can have a better understanding of developing pre-test and post-test. I'm also curious to see if there would be a different outcome with an ELL class versus a class with no ELL students. I wonder if the EDP is more helpful or less helpful in these environments. I'm also interested to see a science lesson compared to a STEM lesson to see if students have better comprehension after a science lesson or after a STEM lesson. At the end of my professional development, I asked the teachers to use their QR code scanners and answer these 3 short questions on a survey. Here are the 3 questions I asked. What did you learn? What questions or concerns do you have? And is there anything else you want me to know about your experience today? Most of the feedback that I got was positive. There was some people who were wanting to see the data from their classes, but like I said, I only tested 2 classes from each grade level. So this was very useful to look back and reflect on. And the last is my references, and this completed my professional development plan of my research.